Hello, my name is Derek, and today I'm going to show you a little video on how to construct an improvised cluster on the University of Michigan computer lab computers using SSH and this program called GNU Screen. So I've logged into login.engine.umich.edu, and you'll see they have this nice command set up called host info that shows you the status of all the regular computer lab computers. It tells you what kind of operating system it's in this column, and how many people are logged in, and whether or not any of those are actually people sitting there. And you can give it a more useful version by asking for ones we can actually SSH into. The interesting thing is, if I take, say, this one, and SSH into it from another University of Michigan computer on the CAEN system, it won't ask you for a password. So that kind of gives you the idea that you can set up your own systems to kind of automate all of this. And if we look at the CAEN fair use policies, they kind of actually encourage this kind of thing. But there was some things you got to keep track of, like we're going to be starting background programs to do calculations. So if somebody else actually comes to the computer and uses it, they have priority, and you have to kill the program. And this system I'm going to show you just a little example of, it does all that. So I'm going to go to my folder that has all this stuff set up in it. I call it a clump, not a cluster. It's just kind of a name to keep track of things. And I'm going to run this little startup script. And this will begin this command called GNU Screen. And it allows you to sort of act like you have a bunch of terminals in one terminal window, or even one terminal tab. So it says screen 0 up here. And it started MATLAB, and if I press Control A and D, it brings me back to the main terminal. And you can do a command like that to show you all the screens you have. So I don't know what, if you want to call it screens or whatever, all the different terminals you can control. So you can go back to one of the existing ones like this. And now I'm going to do a little startup command again, and just run this little example. And what this is saying is, I'm gonna save my data files with this header, this word clump1, and then it'll add stuff to that, and it'll save MATLAB files. And I can use up to 20 nodes, and on each node I'll be using 4 processors. So I just start this, and as it's going, you can see it's just going to automatically connect to any available Linux computers that don't have any users on them. If I go back to my regular command line, you can see that I can actually go into any of these. So if I go and say I want the 6th one here, the 6th one, just do, and you can see there's quite a bit of overhead with this. It's just starting up the computer, and eventually the main loop will send it a command for stuff to calculate. And that's going on here. So it's sending commands now. Just to give you a little idea of what it's calculating, I have another tab here, just MATLAB on my computer. It does a little analysis on this hypersonic vehicle code I've designed. It looks like that. And just to give you a sample, each thing it's sending to one of the nodes does a trim calculation like this. So I've set it up, I want to go Mach 8 at altitude of 26 kilometers, and I'm trying to get to space, I guess, so better not be steady level flight. Flight path angle of 3 degrees, accelerating at 3 meters per second squared. And it's just going to go through the residuals until it meets all those flight conditions. And as soon as it does that, which should only take a couple seconds here, there we go. Give you an idea of like what kind of flow solution it's doing, and flight dynamics. Oop, that was the wrong command. Here's just a little drawing of the inlet as soon as it loads. There we go. So you can see it's doing this for each attempted evaluation here. It has to calculate all these things. So it's a pretty good example of something to use distributed parallel computing for. And this is kind of interesting. I can stop this command. Eventually it'll stop. And if we look in here, I think my data folder, see it's populating with all of these partial computations. So each one will just be one trim. And that pretty much gives you the idea of this. So I've improvised my own cluster, and I don't have to queue or anything, and it's using resources that are readily available. And that's about it. I hope you enjoyed, and if you're interested in any details of how this worked, just send me an email.